Hi, it's Alec again, doing the next interactive assignment. I went ahead and practiced this one before I did it, so I'm just going to explain what we're trying to do today before we do it, and then I'm going to try to explain the process as we go. So our project today is trying to clean pennies, but explain why it is that that experiment or that reaction is occurring. So to give you an example of a dirty penny compared to a clean penny, I'm going to hold these two up. You can see that the one on my right, so this one, is the shiny penny, it's cleaner, and then this one is the dirty penny. Alright, so what we're seeing here with these two is that this penny, not completely clean, but this penny, the copper on the outside of it, is the main element that we're seeing, and then over here on this dirty penny, the dark spots and the dullness, that is caused by this penny over time, the copper reacting with oxygen in the air to cause copper oxide to be present on the outside of the penny. So that copper oxide is what causes the copper itself to kind of lose its dullness appearance. Most metals will have a shiny appearance. They're able to be flattened so they're malleable, so we're able to manipulate them into different shapes. They're good conductors, so those properties exist for all metals. Now, the thing about the dullness, though, it's turning dull because it's not just a metal anymore. It is the copper bonded with oxygen to form the copper oxide. So what we're going to do is the dark pennies, we're going to put them in a solution of vinegar and salt. We're going to let them sit for a minute. I've already prepared the salt and vinegar solution with a fourth cup of vinegar and then a teaspoon of salt. So I'll go ahead and drop some of those dirty pennies in there. We'll give them a minute just to start seeing what happens. Shake them out so they spread out a little bit. Okay, so again, I'm just kind of observing this as we go. But what the idea is that the vinegar and the salt function as kind of the acidic, a weak acid that's going to cause the oxide portion of the copper oxide to break off or separate. So what will happen is that weak acid will take the oxide and copper ions, some of them, into the solution, and so that will pull some of that copper oxide, or some of the oxide off, leaving just the copper to show. So already in the cup, we're starting to see the pennies are showing a greater shine. Again, kind of resuming that original property of a metal, that it is shiny, lustrous, that kind of a thing. What we'll be doing next is I've got a cup of water here as well, so showing the pennies in the cup, and then these are the clean pennies from earlier. What we'll do is we'll take the pennies out of the vinegar salt solution and put them in water. And the reason that we do that is because when we're taking them out, we're going to put them in a solution that's going to stop that reaction. So H2O is able to serve as a solvent that will stop that reaction. So if you think about it, these copper pennies that now have a slightly increased charge due to some of the copper ions and the oxide coming off of it, they will then be thrown in another mixture of just H2O. And so over time, what we could kind of expect is some of the oxygen from H2O to bond with the copper again. And so if we left them in for a long time, it probably would start to resume back to what the copper oxide on those dirty pennies look like. So I'm going to lift up out of the vinegar one of these pennies again to show you. See, it is much cleaner than what that original penny was. So I'm going to go ahead and throw these in the water with the others to stop that reaction. So all in all, there are now 10 clean pennies in this cup of water solution. And the thing to keep in mind, I guess, with any of these reactions is that sorry, I lost my train of thought, but basically, this whole reaction is showing the property of copper as a metal, its ability to bond with oxygen to form copper oxide, and then we're able to break that down with an acid, so the salt and the vinegar, and then when we transfer it to water, it stops that reaction